Hello everyone, my name is Hannah Holbert. I am a zoo science senior in the aquarium track, and today we're going to be talking about one of my favorite animals, the horseshoe crab, specifically the Atlantic horseshoe crab, Limulus polyphemus. So a lot of you guys have probably seen horseshoe crabs before. They're pretty common in aquariums, and they can be found specifically in touch tanks most of the time. So you've probably interacted with these guys at least once in your life. But we're going to talk about some general characteristics of them just in case you haven't, or maybe you don't know very much about them. So horseshoe crabs are arthropods. They're actually more closely related to scorpions than they are to crabs. They've been around for almost 400 million years, and they're actually pretty closely related to trilobites in terms of being the most closely related of the extant species. They haven't changed much over these 400 million years morphologically. They're pretty much the same. They haven't had to adapt very much, and we can see that in the fossil record, which is pretty cool. Um, our living species can get up to 20 years old in the wild, and they actually sexually mature around 9 to 10 years old. It is common for these guys to reach higher ages in captivity. In the wild specifically, these individuals do get pretty big, specifically our females. They can get to 12 inches across the prosoma, which is the top section of the shell where the eyes are located, and then they can be 24 inches long, which is the top of the prosoma, all the way down to that tail-shaped appendage, the telson. Our females are normally pretty large, getting up to 11 pounds in weight, which is a very, very big horseshoe crab. Normally you're not seeing horseshoe crabs this big, and the ones you're seeing in captivity tend to be males, so the breeding doesn't occur, and they're usually a bit smaller. So unless you're looking for them in the wild, you're probably not going to see them at this size. Their current IUCN Red List ranking is vulnerable. I do want to talk a little bit about the horseshoe crab anatomy that I brought up because it is very important and characteristic of these animals. You're not really going to see this in a lot of other organisms. So if you take a look here at these two different diagrams, they're showing us pretty similar things. You can see only top half of the shell where the eyes are located. Again, this is the prosoma. This is where they get their name, as it's horseshoe shaped. Looks very much like the foot of a horse. The back part of the shell is the opistosoma, which is where the book gills are located underneath, and you can actually see there's some spines that come off of the end of the opistosoma. Then from the back of the horseshoe crab, we have the telson, which helps the horseshoe crab right itself if it does fall on its back. I actually have a video of this to show you guys later. And then if we look on the underside, we can see their mouth is in the middle of their prosoma, which is pretty interesting, in the middle of their legs, and they'll use those walking legs and pedipalps, which are the top legs. The first pair of legs are the pedipalps, to push food into their mouths. Then you'll see their book gills, which again help them breathe, but also can be used to flip themselves over by creating a current underneath them. To get into a little bit of the taxonomy here, just to give a broader overview of what we're looking at, we have phylum Arthropoda, class Meristomata, which is telicerate arthropods. We have order Ziphrocyrdia, which is arthropods specifically related to scorpions. And then we have family Limulidae, which is horseshoe crabs only. Then we can get into our genera. We do actually have 3 genera of horseshoe crabs. The genus we're talking about today is Limulus, but we also have Tachypluis and Carcinoscorpius. I found this very large tree here that I wanted to show you guys because it does show some of our extinct and extant species. I have the 4 species that are extant today in yellow, and you can see that there's quite a few that are not currently living today. A lot of their ancestors have passed. So the 4 that we have today are the only ones that are currently outstanding. So I do want to talk a little bit about these 4 species because I do find them to be important, especially because they have important statuses on the red list. So again, the first horseshoe crab in the top left is Limulus polyphemus, the Atlantic horseshoe crab, which many of us know and love. He is currently listed as vulnerable on the red list. On the top right here, our second horseshoe crab we can see is Carcinoscorpius rotundicata. This is the mangrove horseshoe crab, and these guys are actually data deficient. So, for how loved horseshoe crabs tend to be in the media and general culture, you would think that there would be more information about the overall different species of horseshoe crab, but that tends not to be true, which actually did surprise me. We can look here on the bottom left and we can see Tachypluis tridentatus, which is the tri-spine horseshoe crab. These horseshoe crabs are listed as endangered, which is really important. The three species we're looking at here are all Asian species other than Limulus polyphemus. So the fact that they have three, only one of them actually has a status, and it's endangered with the status it does have, is very important, and they need to be pushing for more conservation efforts over there for these guys. The last species here on the bottom right is Tachypluis gigas, the coastal horseshoe crab, which is also data deficient. So out of the 4 horseshoe crab species that are currently extant, 2 of them are data deficient, and the other 2 are listed as vulnerable and endangered. Things are not looking very good for these guys in general right now, which is very sad, and most of them are being impacted by declines, and we'll see some of these other reasons for this decline later on. So our horseshoe crab, Limulus polyphemus, we're going to talk about these guys just a little bit before we get into some other general characteristics. They are, again, native to North America, the only species native to North America, and in this distribution map here, you can actually see the different locations along the coast that they are found in. So you can find them all the way up in the Gulf of Maine, through the Mid-Atlantic, through the Carolinas and Florida, all the way into the Gulf of Mexico. And actually you can find populations on the Yucatan Peninsula in Mexico as well, but that's pretty much the extent of their range. They are only on the east coast of the United States and parts of Mexico. I did want to point out some of the locations of these other species. Like I mentioned, they are Asian species. Some of them can be found slightly in India and the island chains below. But I did want to point this out because we're seeing that even though these animals are so far apart, they're still all facing very similar threats. So again, Limulus polyphemus in blue, you can see them on our Atlantic coast in North America. And then if you look onto the right side of the map, we have Tachypluis tridentatus, which is the endangered species, and you can see that it runs up through China, Japan, some countries right below then, but it doesn't hit India. It's not that far over west. But the other 2 species that are data deficient, Tachypluis gigas and Carcinoscorpius rotundicata, are both species that can be found in the more southern region of these Asian countries as well as parts of India. So talking a little bit about habitat, we're going to start kind of broad here. Horseshoe crabs generally have 3 areas of habitat that they use on the coast. So these guys are a coastal species. They can be found in shallow tidal waters where they'll be doing a lot of feeding and breeding behaviors. So we can see here, if you look on the right side, that during normal situations and normal conditions, the horseshoe crabs, again, can be found in these lower tidal waters off of the coast where there's lots of vegetation and other plant life, and light still reaches this part of the water. During breeding, which is high tides in the spring and the summer, and we'll talk a little bit more about that later, they come up onto the beach, and you can see that they spawn right out of the water, right out of the tidal zone. Once the eggs hatch, you can see that the baby horseshoe crabs can be found in nursery habitat, just slightly under the tide, where it's rolling in and out off of the beach to keep them a little bit protected from predators such as birds. So this slide's showing us some more detailed images, some real images of where these horseshoe crabs can be found. On the left side, we can see the general habitat of the horseshoe crab. It is in, again, the shallow coastal plain area where there's lots of vegetation and other organisms located. The sun still penetrates this area, so it's pretty warm. And then on the right side, we can see the spawning slash breeding area of the horseshoe crabs. You can see there's a lot of horseshoe crabs involved in this specific type of breeding method, which we will get a little bit more into. But yes, they come up onto the coast, do this breeding habitat, and then go back out into the tide. So I do want to talk a little bit about the breeding behaviors specifically because these are very characteristic of horseshoe crabs, and I'm pretty sure no other arthropod does it the way that they do it. So they do something called scramble breeding, and this is when hundreds of horseshoe crabs will come up to the beach, um, and they will all pair off either in the water or out of the water on the beach. A male will hold on to the female using his pedipalps, and they will move up the beach. The female will drag the male. She will dig an indentation in the sand and lay her eggs in the indentation, very similar to how sea turtles will lay their eggs up on the beach and then cover them back up with the wet sand. You can see here in the image on the bottom left that there's a lot of horseshoe crabs competing for mates, trying to get to the nearest female. Some males will grab onto other males or they will form chains, which is very common. They are just trying to fertilize any eggs that they can. The males actually externally fertilize the eggs, so once the female is laying them, he will fertilize on top of them, and then they will again bury those eggs. You can see here on the picture on the right that these eggs are very small. They are pea-sized, smaller than a pea even, and these horseshoe crabs will develop and then hatch and be ready to move out by the next new moon. So it's about a month or so from when they are laid, and they're very small. So these horseshoe crabs will come up to the beach and be very tiny, which puts them at risk from predators. And baby horseshoe crabs are actually one of the main food sources for a specific bird called the red knot, which is also facing a lot of population decline. So these horseshoe crab populations impact a lot of other species that feed on them. So when our populations are declining and these behaviors cannot occur, other species are being impacted as well. So now that we've talked about breeding behavior and overall habitat, we can talk about their diet. So their diet tends to be pretty generalistic, which is why these guys are very successful with where they live. They can eat mollusks, normally clams and mussels. They also eat marine worms, and they will eat vascular plant matter and algae. So they're, again, very generalistic. They can eat any of these things and will be satisfied. They'll kind of eat anything they come across that they can eat, which is pretty interesting. So some fun facts about these animals. I did mention earlier that they are the closest living relatives to trilobites. You can see here in this diagram that they have very similar body plan characteristics that we went over earlier. So you can see in blue, when it highlights, is the prosoma, and then we have the opistosoma located in yellow and the telson in pink. So you can see that although the body plan is not identical, they do share a lot of interesting characteristics with trilobites, which means that they definitely could have evolved or adapted off of the same line, which actually is proven considering they are relatives. So another fun fact is that we talked a little bit about the sexual dimorphism through the mating use of these pedipalps, but you haven't actually seen what they look like. So there is sexual dimorphism of horseshoe crabs, not only in the pedipalps but in the size. So horseshoe crab females are normally a lot larger than males, and their pedipalps will look slightly different. So female pedipalps will look like the walking legs. The rest of the walking legs, there's no special appendages or adaptations here. But on the males, which you can see on the right, the finger, if you will, the tarsus of the pedipalp is shaped like a hook, and the tibia is much larger. It's more ball-shaped. A lot of people in circles that work with these horseshoe crabs tend to call these boxing gloves. So, when you see a boxing glove on a horseshoe crab, you know it's a male. That's essentially the first thing you know. It will always be consistent. Females will have pedipalps that look like walking legs, and males will have these boxing gloves. So another fun fact we can talk about is something I mentioned previously, how horseshoe crabs can use their telson to flip themselves upright. You can see that here in this image. I did have a video, but the videos won't work for some reason on Microsoft when you're recording. So the horseshoe crab will angle their body so their telson is facing upright, and they will use their book gills as well as their walking legs to kind of make some momentum, some movement, and it will rock themselves up and forward. Usually this works a little bit better in the water. They have a hard time when they're on the beach, and actually will often get stranded because they use those book gills to make a current when they're in the water, and it will help propel them upwards. When they're on the beach, you don't really have that option. So half the time, these horseshoe crabs are getting stranded. So if you do see one upside down and he's struggling, you can gently grab the edge of that prosoma, which you can see here, that top half of the shell, and flip them over. Please do not grab them by the telson or any other part of their body or handle them for too long if you are flipping them over, because it does cause a lot of stress and you can break or damage the telson if you do grab it. So we can talk now about some other impacts that are important for these horseshoe crabs, which is their means of imperilment. So there are three overarching issues with imperilment, which includes overharvest and overcollection, climate change, and urbanization. We'll get into each one of these independently, but I just wanted to give you a general overview of what we would be covering. So the first thing to talk about here is overharvest. So overharvest is very common because these animals are very popular in the pet trade, but also used as bait for whelk and eel fishing, in fisheries specifically. So they collect a lot of horseshoe crabs for use as bait. The pet trade doesn't even come close to the same amount of numbers. They actually reached a high point in collection of these animals for fisheries at 3 million horseshoe crabs harvested in 1998. Recently, the Atlantic State Marine Fisheries Commission has actually moved to set quotas and season closures to kind of prevent this continuous overharvest, which actually has lowered numbers recently to about 600,000 to 750,000 animals collected per season per year, which is a lot better than 3 million. So we're moving towards a point where this could be better, but it is still a very large issue because they are still used as bait. Another big thing that impacts overharvesting is the collection for biomedical use. So, but the biomedical field uses a compound known as limulus ambibiosite lysate, also known as LAL, which can be used to detect the presence and concentration of bacterial endotoxins in drugs and biological products, which a lot of people will notice is vaccines. Some people have heard of this before, some people have not, but it is very common for them to pull this blood out of the animal in a collection setting such as the one seen on the right image, where they are putting a needle through the main artery that goes between the prosoma and opisthostoma, and they drain as much of this blood that they can to get this LAL. A lot of these animals are returned to the sea, but over 30% of those who are released will die. It is very common for these horseshoe crabs to die after being bled because they are bled to the point of exhaustion and having no blood left in their body in some cases. And when they die in the lab, they tend to just be thrown away. So those horseshoe crabs that do escape, 30% of those will die, which is very sad. So we can talk a little bit about climate change here. There are a couple different things that impact the horseshoe crabs in this manner. So I would say the first thing would be ocean acidification. A lot of us know that this means a change in pH. When carbon is sequestered in the ocean, it changes the carbon cycle, and more bicarbonate and carbonate can form in the ocean, which opens more room for CO2 to enter the ocean. Again, making the ocean more acidic, and this will just continue and continue endlessly, so that it's just always going to be more acidic over time. This change in pH is actually harming a lot of individuals, including horseshoe crabs, because they're used to a range between 8.2 to 8.5. If our ranges are getting more acidic, these animals are not adapted to live in these ranges, so it is greatly impacting them. We can also talk about the ecological changes in this coastal habitat that they utilize, because again, they need this coastal habitat not only for just general living when they're in these shallow pools, but also the coastal regions that they spawn on, and they do these breeding behaviors. So as ocean levels rise due to the ice melting and temperatures rising, we're losing a lot of our coastal areas. So there's a lot of erosion that occurs, and as we lose the beaches, there's nowhere for the horseshoe crabs to come up and lay their eggs. And with no habitat, no horseshoe crabs can be born. So, it's a large population decline. As things continue to get worse, we're going to see less and less horseshoe crabs because they have nowhere to breed. And our last big issue of imperilment is urbanization and human development. So in this image here, you can kind of see that the beaches are being built upon and these large rocky outcrops are being placed. And sometimes the beaches are just outright being removed, or there's a lot of trash and building debris on these coasts. So the overall destruction of coastal areas for development is really impacting these guys. Again, they don't have any breeding habitat when you're building on top of them. So people are building homes that they use only in the summer. They're using these beaches for entertainment and putting in, different activities to do, different buildings. And the debris, like I mentioned, the debris is entering this coastal habitat. It's destroying the habitat they live in seasonally during this breeding time, but also the habitat that they live in normally. The trash is floating out into the ocean. It's impacting these guys. They could be eating the trash. The pollution could be impacting them. So there's a lot of factors that go along with this that could definitely be impacting these horseshoe crabs. So we can talk a little bit now about the overall population's viability. So what we're seeing because of all of these issues is an overall decline. They're currently listed as moderately depleted by IUCN, but they do have a 69% population viability on the IUCN website listed if conservation efforts are continued, but within the next 100 years, they do have a 0% recovery rate if things do not change, especially relating to climate change and coastal erosion, because these horseshoe crabs will not be able to spawn. Their current overall numbers are unknown because they do live in the coastal regions and only come up for spawning. It is a little bit hard to get numbers on these guys, but overall, we're seeing a general decrease. If we do work with conservation efforts, again, there is a 69% population viability, but we won't see that unless we actually start making a change. So how do we do that? Well, there's a couple different recovery efforts that are going on right now. So we can talk about our general public education, public outreach groups. This includes aquariums. This includes a group called the Horseshoe Crab Recovery Coalition. So these guys both are doing a lot of education and outreach about horseshoe crabs, about the current status and what we need to do to save them. Some aquariums are also doing conservation efforts, propagation, or funding for these conservation groups so that they can do more research and write more papers and things like that. So we're actively trying to help this community and the aquariums. As a zoo sci student who works in an aquarium and wants to work in an aquarium, I like to see that these aquariums are doing outreach as well and providing money to these conservation groups. Um, we're also seeing education on the overall government side of things. So when we're talking about government restriction, we can see that there's a lot, again, of funding for propagation programs and recovery programs, which are funded by the government, but also through fundraisers and other outreach programs. Um, there's also new limits and quotas on catching horseshoe crabs. So they're trying to stop people from catching female horseshoe crabs because, again, the female horseshoe crabs are the ones who can lay the eggs. They're trying to do seasonal closures so that during breeding periods, no one is catching horseshoe crabs. Um, so you can see here that in this graph, that they're talking about the collections for bait and biomedical collections, and you can see that with policy and restriction from that high period in 1998, where again there were close to 3 million horseshoe crabs collected, we have decreased quite a lot, especially in the bait use. We are seeing an increase in biomedical collections, but we'll talk about that in a little bit, and how we can decrease that. But for now, these restrictions are actually really impacting the bait industry and the overall collection for things like that. So we're reaching a good point in what we can do, and hopefully we'll slowly see these numbers continue to decrease. Actually, we hit a point where there were 475,000 male horseshoe crabs collected in the 2022 area 2023 season, and zero female horseshoe crabs were collected. So again, with these specific quotas and limits, we can provide more survivability for these horseshoe crabs by not impacting them or taking the females that are currently breeding. So another recovery effort that we can talk about, like I said, relates to the biomedical industry because, like in the last graph, you could see that um, our biomedical industry is starting to take more horseshoe crabs by overharvesting, while our bait industry is slowly decreasing due to government impacts. So there are actually alternate sources of LAL, compounds that mimic LAL, that have been researched and found recently. um, these compounds are called recombinant factor Cs or RFCs, and they're synthetic alternates. So these have been developed and can actually reduce horseshoe crab need by 90%. So we can reduce the populations of horseshoe crabs that we are pulling from. We can reduce the total number of horseshoe crabs that the biomedical industry is using by 90%. That is a lot. And we saw how quickly those numbers were rising. So this is a very big deal. Before horseshoe crabs were used, actually, these studies for vaccines and stuff like that were actually used on rabbits. But there's definitely ways that we could artificially recreate these and replicate these tests with this synthetic alternate, um, rather than continuing to use live animals. So we just have to make a push for this. We need to explain this more to the public and get this more in the, again, the public eye so that people know about it, so that the biomedical industry will push in this direction because there is a public outcry. So I did want to show you guys my logo slash slogan that I made for the horseshoe crabs. So it's "Don't get grabby, save the horseshoe crabby." So it's a bit silly, and it's a picture of someone grabbing a horseshoe crab, and you shouldn't be doing that because, again, over harvesting, over collection, people taking these horseshoe crabs off the beach, just in general. We have a lot of beach goers who will go down, see these horseshoe crabs, and pick them up and mess with them and cause extra stress, or take them home, which is not a good thing. So I feel like it's really important to leave these individuals alone on a massive scale with the fisheries needing them for bait, as well as the biomedical departments, and just the general public needs to leave them alone. We don't need to be touching these horseshoe crabs unless they're flipped and they need help, which the Horseshoe Crab Coalition actually has some slogans and logos that they talk about, some educational flyers where they talk about flipping horseshoe crabs, so that's already covered. But I feel like a general note needs to just be, don't mess with the horseshoe crabs, let them do their thing. Let's just support them through public outreach, through funding of these propagation and research programs. There's so much we can do without being hands-on for the horseshoe crab. Thank you guys for listening to my presentation. Here's my last slide here with my bibliography, all of the papers that I looked into if you guys are interested in researching more about horseshoe crabs, or if there's something specific about breeding behavior or the ecological impacts that you would like to look into. There's also some IUCN resources here. But with that, thank you guys for listening and have a good day.